Hello everyone, welcome to low power VLSI tutorial. This is the first lecture of second chapter. The syllabus in Unit 2 is MOS inverters. Its introduction, how MOS inverter works, and other things will be discussed here. How can we design a MOS inverter? What are the design criteria and all. Next is inverter and its characteristics, configurations, inverter ratio in different situations, switching characteristics, delay parameters and driving parameters. Driving large capacitive loads are the main topics. The second half of this unit is MOS combinational circuits. Introduction, it's a pass transistor logic, gate logic and MOS dynamic circuits are the important topics of this second half of the second unit. Now let us begin with the introduction of MOS basic inverter. Every inverter will have a pull up network and pull down network, because as you can see from the screen, the basic inverter diagram is shown. Circuit symbol is shown here. Now from this circuit symbol, what does it mean is, input we will be applying here, we will be getting the output. Whatever the input, like if you apply one logic 1, you will get a logic 0 as the output. So the basic property of an inverter is to convert 1 into 0 and 0 into 1. When you input 0, it will produce 1. When you input 1, it will produce a 0. How will it do? It will be having basic inverter is CMOS inverter is a basic inverter, not CMOS. This inverter will have a transistor which acts as the inverter. A single enhancement mode, NMOS enhancement mode transistor acts as inverter, that will be enough. If you don't have the pull-up network as shown in this device, in this circuit, this is the pull-up device. If you don't have the pull-up device, when you apply logic 1 as the input, transistor enters into saturation region, providing a conducting path from its drain to source. That means it acts as a very low value resistance. When there is no pull-up device, it is directly connected to the supply voltage. So when the supply voltage is short circuited to the ground through a low resistance device, there is a possibility or tendency of blowing up of this device which is acting as the inverter. So to protect the device, we need to add a pull-up device in its drain circuit. The role of this pull-up circuit is to protect the device from overcurrent breakdown. So the role of this pull-up device is to protect the pull-down device. Why it is called pull-up device and why it is called pull-down device is, we are in VLSI, we always consider load as a in the other amplifier circuits and all, we have considered we normally consider RL, load resistance, as a load. Here we are considering CL, load capacitance, as a load. Now if this device, pull down device, is on, if this pull down device is off means V input that is applied is 0 volts. For 0 volts, this device will be off. Now the charging current that is flowing through the pull-up network will be flowing through the pull-up network and passing through the load capacitor which is connected from output to ground, causing the voltage across the load capacitance from 0 volt, which is very low, to a peak. Now what happened? The current which has flown through the pull-up device and the load capacitor has made the output from 0 to high. What it did? It has pulled up the voltage level. That is the reason why the color drain circuit of the inverter is called as pull-up network. Let's discuss why this is called as pull-down network. When you apply a logic 1, that means 5 volts here, example, this device turns on. That means there is a short circuit between drain and source. This short circuit will obviously hold a resistance which is less than the pull-up resistance. Now the capacitor, load capacitor, which was fully charged, will now get discharged through this transistor. As the voltage level which was at the high has been made to low by turning on this transistor, so that is the reason why this device is called as pull-down device. This is the device which is making the output become 0. So that is pull-down network. I hope you understood what is inverter, why we need a pull-up network and why we need a pull-down network, why we call them pull-up and pull-down and all. If you have any doubts, you can leave a comment in the comments box. Thank you.